20 years ago, two astronomers made a remarkable discovery, one which would change the way we view the universe forever.
A planet outside our solar system orbiting a distant star. An exoplanet.
Since then, we've found worlds where it rains diamonds, ones that boil at 3,000 degrees centigrade, and even a world with 4 suns in its sky.
But the big question is, will we ever find another Earth? Welcome to the Sky at Night. Our solar system is filled with an incredible variety of planets. From small, airless and rocky worlds like Mercury, to gas giants like Saturn, with its spectacular rings of ice.
Surely our solar system couldn't be the only one to host such a wonderful variety of worlds. And yet, until the 1990s, astronomers hadn't found a single planet outside our solar system. And then, in 1995, they found it, the first really convincing evidence for a planet orbiting another star.
Since then, we've discovered nearly 2,000, and it's involved some pretty extraordinary science detective work.
In fact, we've found so many planets that we've reached a remarkable conclusion, that almost all the stars in our galaxy have their own families of planets.
It's a really hot topic in astronomy right now. We're all desperate to find another Earth.
Although, as we'll see later, quite what that means is still open to question.
Coming up tonight, we'll be examining some of the latest discoveries made here at the Cambridge Exoplanet Research Centre, and finding out how the hunt for a second Earth, a habitable planet like our own, is coming along.
We have found planets in all size, in all masses, and in many different kind of structure from the one we have in the solar system.
Hollywood has no doubts that there are habitable planets out there. Dallas Campbell finds out whether exoplanets in the movies have any basis in reality.
And you can see there's the binary star. One is a little bit whiter, the other one's a little red.
Almost exactly like in Star Wars.
We'll tackle a controversial discovery that my own research group have been involved in. Could this really be the first discovery of an alien civilization?
But first, how do you go about finding an exoplanet amongst the 100 billion stars in our galaxy? The first true exoplanet was discovered by two astronomers in 1992. Scientists found not just one, but at least 2 planetary objects orbiting around a star. It was a stunning achievement. These planets were 4 times the mass of the Earth and orbited a type of star called a pulsar, a remnant of a supernova. Because the pulsar permanently bathed its planets in high-energy radiation, there was no chance for life. So in terms of finding another Earth, these planets were non-starters. Nevertheless, it was a thrilling discovery and left us hungry for more. What we wanted next was a planet orbiting a main sequence star, just like our own. And in a small observatory in France, a young PhD student struck lucky. Didier Queloz discovered a planet around the star 51 Pegasi. 51 Pegasi was the right kind of star, one that wouldn't bathe its planet with deadly radiation. But in other respects, the planet in orbit around it was spectacularly weird. It was the size of Jupiter, yet it took just 4 days to orbit its star. And its surface temperature exceeded 1,000 degrees Celsius. It was a type of planet that has come to be known as a hot Jupiter. It was an extraordinary discovery that rewrote our understanding of what exoplanets might be like. And it was just the beginning. I caught up with Didier to find out more about his original discovery and what he's been up to since. Tell me about the day you discovered 51 Pegasi b.
Yeah, I was a PhD student at the time. So the first time I saw something a bit strange going on the series of measurements I made on 51 Peg, I never thought it would be a planet because it was just impossible. I thought it was a bug into the instrument. Something was wrong with the instrument, with the machinery. And it took me a long time to figure out exactly what it was.
Did you hope that the planet you discovered was going to be Earth-like?
Well, it was impossible because the instrument we were using, the best it could do is detecting something like Jupiter. And it was designed to do that. That was already a tremendous achievement at that time. We can do Earth right now, but 20 years ago it was not possible. But it was already so much amazing to find a planet so bizarre than this one. So I didn't care at all. I mean, it was really a kind of game changer situation.
So what method did you use to find 51 Peg?
So at the time, the only way to find a planet was to observe the stars. And by observing the star, we were measuring the speed of the star, looking for a tiny change of that speed.
So you have a star,
Yes.
and you have a planet going round it.
Right.
And as the planet goes round, it causes the star to move by a little bit.
Yeah,
And you're measuring that movement, that speed.
It's a very tiny effect. You don't see it right away. You need to use quite sophisticated algorithms to build the average motion that tell you at the end that there is something orbiting that star.
So that's one method. But are there other methods for detecting these exoplanets?
People started to look for transit at that time. What will happen is there will be, for a short amount of time, a slightly change of the light, a dimming of the light of the star, like a cloud, just hiding us the sun. We can use that to get the size of the planet as well as the period of the planet. We can also combine the two. You can get the mass from the radial velocity and you can get the size from the transit. And we're doing that today to get the density of the planet. And the density helps you to understand the structure of the planet. And that was really the beginning. So it was a massive trigger. And that's why at that time we were maybe 20 people in the world doing that. No, there must be 5,000 people working on this.
So we've found these hot Jupiters, and now we're finding sort of smaller and smaller planets with a better sophisticated equipment.
Yes.
Do you ever think we'll find another Earth?
Oh yes, I mean, we have found already Earth-sized planet or Earth-mass planet. Most of them, they're not exactly Earth equivalent because very often they're too close to the stars, much too hot. So we don't really know what we're finding these days, but we have planets in all size, in all masses, in many different kind of structure from the one we have in the solar system.
So yeah, we're finding more and more, and hopefully that another Earth will be out there one day.
Oh yeah, there are, because right now we're finding, in average, one planet for each star. So if you look at the star tonight, on all the stars you're seeing by the naked eyes, there are planets. Some of them we have found them, others we have not yet found them. It means that maybe they are solar system equivalent, just waiting for us to be found.
Exciting times ahead.
It is definitely exciting, yes.
Well, thank you. That was wonderful.
As we hunt for a second Earth, we have to think about what it is that we're really looking for. What is it that makes a planet Earth-like? Is it rocky? Is there liquid water on its surface? What gravity would it have? And would we be able to breathe if we were standing on the planet? Astronomers are only just beginning to work out what conditions are like on exoplanets. But that hasn't stopped Hollywood from creating its own alien worlds, and most of them are very habitable. Dallas Campbell investigates how plausible Hollywood's exoplanets really are.
I went to see Star Wars when it first came out, age 7, at the ABC Cinema Haymarket, Newcastle upon Tyne. And it was one of those cinema visits that will be forever etched on my brain, and it ignited my lifelong love affair with science fiction movies.
Amazingly, many of the distant worlds featured in these films were being imagined by writers and directors decades before the first exoplanets were found.
The planet Tatooine from Star Wars, for example, you've got this wonderful, evocative desert landscape, and Luke Skywalker stands there contemplating his destiny, bathed in the afternoon light from not one, but 2 suns. Although it has two suns in almost every other respect, Tatooine feels reassuringly Earth-like, which makes sense given that it was filmed in Tunisia. But the same can't be said for this planet.
If I owned this place in hell, I'd rent this place out and live in hell.
This is Crematoria from the Chronicles of Riddick. And in it, the protagonists have to deal with furnace-like temperatures during the day, so up to 372 degrees. And then at night, it gets down to minus 182 degrees, with only a 20-minute window where the characters can actually walk about safely on the surface. Interstellar is about the search for a second Earth. As food resources run out, humanity must find a new home. And en route, they have a close encounter with a very strange water world called Miller, which has 30% more gravity than Earth, huge tidal waves, and is orbiting an enormous black hole called Gargantua.
It's our only chance to save people on Earth. If I can find a way to transmit the quantum data I'll find in there, they might still make it.
Let's just hope there's still someone there to save.
So that's just a few examples of the artistic license used by writers and directors in describing exoplanets. But what about real life? How close are we to finding anything like what we see in the movies? Well, I'm going to go and see exoplanet expert Ruth Angus to find out. So how realistic are some of these exoplanets that we see in the movies? I guess the most famous one is Tatooine in Star Wars with its binary star system.
Yeah.
Could something like that happen? If so, have we found anything like that?
Yes, absolutely. We found more than one, actually. The first one we found was Kepler-16b. We found it in 2011. And it's the first circumbinary planet. So that means it's a binary star, two stars that orbit each other,
right,
and a planet on the outside that orbits both of them. So the planet has
So the
two
stars are orbiting each other in a
Yeah.
little sort of merry dance, and the planet's going around all... Oh, wow.
Exactly,
Okay.
yeah. So here's a video of that system. And you can see there's the binary star in the center. One is a little bit more massive than the other, and it's slightly whiter.
Yeah.
The other one's a little red.
Almost exactly like in Star Wars. I have to say, it's got a red one.
Almost exactly like in Star Wars.
And
yeah.
is the planet that's orbiting this system, would it be a rocky planet looking a little bit like Tunisia? Any chance?
We should be so lucky. No, unfortunately, this planet is a Saturn-like planet. The reason why this was such a benchmark system is because before we found Kepler-16b, we didn't actually know whether you could form an exoplanet in a binary system. And that's because the gravitational pull acting on the planet varies all the time because these two stars are moving. So that means that the planet is kind of like walking drunkenly around in space. And if that kind of drunken walk gets too extreme, it's going to spiral inwards and plunge into the surface of one of the stars, or it will be flung outwards completely.
Right.
So we didn't know whether we'd find any planets actually in stable orbits around binary stars. Kepler-16b showed us that they do exist, and we can find them.
What about some of these exotic exoplanets that we see in the movies? Something like Crematoria, which is the aptly named planet in the Chronicles of Riddick, this sort of extremely hot during the day, extremely cold at night. Is that just complete fantasy, or is that possible?
Well, we have managed to map the temperature on the planet WASP-43b. So we actually know what the temperature of the day side is, and we know what the temperature of the night side is. And in this graphic, we can see in the day, it's really hovering up around 1500 Kelvin, and then at night, it drops all the way back down to almost to zero.
I find it amazing that we have the technology that enables us to do that. One of the things about Planet Miller in Interstellar is that it's orbiting a black hole, and you get into all kinds of exotic physics, time dilation, all this sort of stuff. But the fact that it's orbiting a black hole is a really interesting idea. Is that at all feasible?
Yeah, there's no reason why you can't have a planet orbiting a black hole. And in fact, there is some evidence to suggest that we've even seen a super Jupiter being eaten by a black hole. And so this graphic shows you. So this is the planet here, and the black hole is somewhere in here. You can't quite see it, but material is streaming from the planet onto the black hole.
I'm trying to imagine what you might see, because obviously a black hole is not actually emitting anything. So what would the view be like?
Well, in this example, you'd see this very bizarre kind of arc of light stretching from you to the black hole.
So what's that? What is that like? Where's that light coming from?
That's the dust and gas falling off the planet into the black hole and crossing the event
So the raw
horizon.
materials that we find that make up planets.
Yeah,
Right.
exactly. So this material, as it's falling into the black hole, gets extremely hot and starts to give off radiation. It glows. So you would see the kind of glowing signature of this accreting material.
Do science fiction writers, are they creative enough, do you think? Do you think actually they're a bit slightly limited by their own imagination? And actually what's really interesting is the stuff that's actually out there. Things like, a super Jupiter being eaten by a black hole and a planet made of diamonds and
Yeah,
this
I'm
sort of
sure
stuff.
that's true. The old expression, stranger than fiction, is absolutely applicable to exoplanets. There are lots of things that we've found that are stranger than things we can imagine. And that's the beauty of the exoplanet world at the moment. We're discovering things that we didn't even know were possible, and new physics is being discovered all of the time.
Thank you very much. That was fascinating.
One of the greatest success stories in exoplanet research has been NASA's Kepler Space Telescope. It has found over half of the exoplanets we know about today.
5, 4, 3, 2, it's engine start. 1, 0, and liftoff of the Delta II rocket with Kepler on a search for planets in some way like our own.
Kepler was launched in March 2009. Its mission was to survey our region of the Milky Way to try and find another Earth. And it's discovered more than 1,000 planets. One of the most interesting findings of the Kepler space mission to date has been the discovery of a class of planets known as super-Earths. They seem to be fairly common throughout the galaxy, and yet none exist within our own solar system. They're larger than Earth, but smaller than an icy giant, and we don't know what they're made of. Are they rocky or are they icy? It remains a mystery, at least for now. Perhaps even more exciting is the recent discovery of Kepler 452b, 1,400 light years away. It's probably the most Earth-like planet we've found so far. It's a rocky world that's orbiting in the habitable zone of its parent star, where there could be liquid water. But there's still a lot we don't know about the planet. For example, what its atmosphere is made of. Kepler has done a tremendous job in finding new exoplanets, virtually everywhere it's looked. But it's not designed to give us the detailed information to tell us what those planets would be like. Our best bet for finding another Earth is to build new instruments that can take a closer look. That's what NASA is doing. Its TESS Planet Finder launches in just 2 years' time. Its mission is to detect small planets orbiting bright host stars. Bright stars will reveal more detailed information about their planets, enabling us to better identify those that are truly Earth-like. Of course, the ultimate prize isn't just finding a planet that is like Earth. It's finding intelligent life. We don't really know how that would manifest itself. But Chris has recently been involved in a discovery that has got some people very excited.
I don't normally talk about my own research on the programme, but in the last few weeks we've announced a remarkable, strange discovery, probably the strangest thing we've seen in the universe in the last 20 years. And according to the internet and the newspapers, we've discovered alien spaceships in orbit around a star 1,500 light years away. That's not quite what happened. We've been running a project for the last few years called Planet Hunters, which has invited hundreds of thousands of people to go online and to look through this data from Kepler and try and find planets. And we found planets, but a few of the volunteers pointed us to this one particular star, which is behaving really oddly. This is its brightness over the course of about 3 or 4 years. And usually most of the time it's fairly stable, but there are these dips, just like you'd expect if there was a planet, but the dips happen randomly. Some of them are huge, so at one point something blocks out 20% of the star's light. That's way too much for this to be a normal planet, and The fact that they're irregular means that this can't be something on a circular orbit that blocks out the star's light again and again and again. Something really odd is going on here. In fact, this is the only star amongst the 150,000 that's doing anything like this. And so the obvious question is, what's blocking the light from the star? We think this might be not exoplanets, but a family of exocomets. So if you have a comet on an elliptical orbit about this star, and that comet has broken up, so that you have a string of comets, rather like what happened to Schumacher-Levy 9 when it hit Jupiter a couple of decades ago, then as each of those pieces of comet pass by the star, we'd see a dip. And so you see there's one here, there's one here, there's one here, and then this sudden flurry of large bits that block light out. But we don't really understand what's going on, and so we should consider everything, including the idea that this is some sort of alien civilization. In fact, people are taking the idea so seriously that astronomers have already pointed radio telescopes at this star just to listen out, SETI style, for any signals that might be coming our way from what's become the most interesting star in the galaxy.
When it comes to finding exoplanets, you need more than even the best home telescope. But Pete's here to show us another way we can all connect with the thrill of exoplanet discovery.
Well, it's actually not too bad an evening. It started off rather cloudy earlier today, but the skies have cleared and I can see some stars shining away up there. There's a bit of haze down in the west, but that was forecast to come in. I'm just glad we can see some stars. What I'm looking for is a huge pattern in the sky which looks like a giant square, and that's the square of Pegasus. And sort of early evening, about this time of year, it's quite high up in the sky towards the southeast direction. Now it's pretty prominent, just look for this giant square.
Once you've located it, look to the right-hand side of the square. Close to the midpoint, there is a faint star, and that's called 51 Pegasi.
Okay, well I think I've got a photograph of 51 Pegasi there, and of course on the back of my camera it'll look just like a regular star. The planet is there, we know it's there, it's been detected and it's been confirmed by a number of different sources. And the planet going around 51 Pegasi has got a name. Its formal name is 51 Pegasi b, but there is an unofficial name as well, which is Bellerophon. And Bellerophon in mythology was the person that tamed the flying horse Pegasus, so it's rather nice being in the constellation of Pegasus itself. So I think with exoplanets and regular telescopes, it's really a journey of the imagination. You can see the star there through the eyepiece or on the back of the camera, but it's your mind that takes you into that system to just imagine what it must look like. Absolutely fantastic.
Go to the website to find out more about how to locate 51 Pegasi, to see this month's star guide, and also to learn about an exciting new project the Sky at Night has been involved in.
This month, we're trying out a brand new BBC messaging tool called Whispering Stars. It's a prototype at the moment, but we'd love you to have a go. On the star map, you can click on any star with a circle round it. Not only will you see information from Pete about that star, but you can also leave your own message. Then I can share a link to that message via email or social media. The recipient can find your message using a computer or a smartphone.
So I've got a new message, so I just have to click to find it, and it points me up into the sky towards whichever star the message is attached to. So apparently I should keep going. No, but this way, it's this one here, which looks like it is Vega. And there's the message from Maggie, which says, "Dear Chris, I know you like astrophotography, but did you know that Vega was the first star to be photographed?" So a message sent through the stars, sort of. And you can go to our website at bbc.co.uk/sky-at-night to use Whispering Stars for yourself. And we'll be using it to try and send you information over the next few months.
Even if we find another rocky planet just like ours, orbiting a star similar to ours, even orbiting at the right distance, there's another piece of information we need before we can confirm we've found another Earth. And that information is the atmospheric composition of that exoplanet. And rather astonishingly, we're doing just that. Chris has been speaking to Niku Madhusudan, who's leading the research into exoplanet atmospheres here at Cambridge.
So we've discovered all of these planets. We know, I don't know, what size they are, what mass they are, but it's not really enough. I want to know what they're like. Do we have any prospect of trying to understand that, of investigating these planets properly?
No, absolutely. So the way you do that is, transiting planets, for example. What the transit method is when the planet-star system is aligned in such a way that you can infer the planet going in front of the star.
Yeah, we see these dips in the starlight, and we say, okay, there's a planet there.
There's a planet there. As it turns out, the dip in the starlight is just a little bit more if you have an atmosphere on top of the planet.
Because the atmosphere blocks the light from the star as
yeah,
well.
Yeah, but the key point is that the atmosphere blocks the light in some wavelengths and not in others.
And so that means if you have a transiting planet, you can say something about what its atmosphere is made of.
Exactly. You can infer its chemical composition.
Okay, so Earth is mostly nitrogen, bit of oxygen, bit of carbon dioxide.
Right.
What do we see on these exoplanets?
Yeah, so the exoplanets that we are most able to study today are the big and hot ones. It's because the bigger the planet, the bigger the starlight you're blocking.
Yeah, the bigger the dip.
The bigger the dip. So it's just easier to find them. And hot, because the hotter the atmosphere is, the more puffier it is. Right, so the bigger it is. There is something called...
So the hotter the atmosphere, the bigger the atmosphere, the more light it blocks.
Right. So most of the results to date have come for these objects called hot Jupiters.
What do we know about the conditions? We know they're large.
Right.
That means they must be made of gas,
right,
mostly.
Right.
What do we know about the atmosphere?
So we are finding less water than we would expect if the planets formed in a solar-like environment.
Huh, okay.
And they could be less by even a factor of 10. One explanation is that maybe these objects have clouds in their atmosphere.
So you're saying the water would be hidden by the clouds?
Exactly.
So you only see the bit of the atmosphere above the clouds?
Exactly. So that's one line.
Wonderfully prosaic, like straight, it's a straightforward explanation. Astronomers being confused by clouds.
Yeah,
it's
exactly. So it's not only on Earth, it's not only a terrestrial experience. Even when you go to exoplanets, clouds are a headache.
Yeah.
But there is a subtlety though. The clouds are not the same clouds we have here. Right. So on Earth, there are water clouds. But these are planets at a few thousand degrees.
Of course, so you can't have...
So you can't have water clouds. So you may have to invoke iron clouds or silicate clouds. If you see rocks on Earth, they're made of silicates. So you might be able to make clouds out of those same silicates hanging up in the atmosphere.
Wow. Suddenly it's a place to me, because we're talking about what they're like.
Right.
I sort of feel they're real.
Yeah.
It's remarkable stuff. We'll come back and see how you're getting on in a few years, perhaps. Thank you very much.
Thank you.
To me, it seems amazing. We've come so far in just 20 years, going from no exoplanets to about 2,000 now.
And turning them from just points on a graph, from just data, to real places with atmospheres and rain and even clouds to annoy the astronomers.
But what I'm fascinated by is, if we did find an Earth-like planet, and maybe even signs of life, what would we do then?
Well, we'd have to go, wouldn't we? If you looked at the sky and you could say that star has an Earth-like planet, the right temperature, with life in its atmosphere, you'd have to send a probe.
It'd take thousands of years to get there.
Well, we still should send something. I mean, maybe not us, but we should send something, just so we know we're on our way.
I have to agree, you're right. That's it for this month. Next month, we have a Christmas special.
We'll be taking an astronomical look at the mysteries surrounding the Star of Bethlehem. Was it just a conjunction of planets, or something more exciting, like a comet or a supernova?
In the meanwhile, get outside and get looking up.
Good night.
Join the 5 Live naked scientists as they debate whether humans should go to Mars. This and 3 other episodes available now on iPlayer Radio. Keeping with our space theme here on BBC4, Horizon investigates asteroids. Next.